3 down, 2 to go. You notice we're skipping lesson 4 in the book that we're using to go through this course in my classes. So we're at lesson 5 of unit 5, even though we've only done 3. So here we go. We're going to do triangle inequality theorem. This one is actually going to be, the last one was kind of easier than the first couple, and this one is even easier than that. So here we go. We're going to do, this is going to be a really, really quick one. So the triangle inequality theorem. This is the only theorem we're going to learn in this lesson. This theorem, I actually quite like this theorem as far as, because this theorem and this idea, the idea that this theorem proves is actually quite useful when you're engineering something or when you're designing something. I've once or twice kind of used this when trying to think through a interesting woodworking project or something and before. So this basically helps you know what size lengths can make a triangle, and let's dig into it. So the triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So it's pretty straightforward. So if we look at this kind of example here, then we can kind of write 3 little inequalities. So because of this theorem, it would say that the measure of PQ, so this length, has to be excuse me, plus the measure of QR. So if you add these two segments together, it has to be that total, that sum here has to be greater than. Now it's important to note that it has to be greater than, not even greater than or equal to won't work. Right? Has to be actually greater than, or else you won't be able to make a triangle. And I can kind of sketch out an example of at least that concept in just a second. So it has to be greater than third size. It has to be greater than the measure of PR. So just to kind of illustrate what we're talking about, if you have two lengths that are the same, you have to have one has to be at least a little bit longer than the other one to make a triangle, right? If they're the same length, then it's never going to be able to have a third triangle that's I started talking about a whole different theorem, and so, forget what I was just telling you. Just remember this thing, and don't be confused by the man behind the curtain. It'll be fine. So you could also write the same sort of inequality for like QR plus PR, right? So the measure of, that's the weirdest looking M ever. The measure of QR plus the measure of PR has got to be greater. So if you add these two, that length's got to be greater than the measure of PQ. And you could finally write the same thing with the third one as well. So the measure of PR plus the measure of PQ has got to be greater than the measure of QR. Right? So you can write, so this always has to be true. So if you add up two things, that length, in order for it to be a triangle, because if it isn't greater than, then that other one is going to be something like this, where they're not actually going to cross. It's going to leave a gap or something along those lines, right? It's never going to quite work. Okay? So this has to be true in order to make a triangle. So let's look at the type of example you might have, the type of problem you might have in a math book. It's different than a problem you might have in an engineering book or something like that. But so the problems that you'll see related to this lesson will be things kind of like this. Is it possible to form a triangle with the given side lengths? So all you have to do to figure out whether this works or doesn't work is you've got to add up the different bits. So 8 plus 15. And is that greater than 17? Well, 8 plus 15 is 23. So, yes, that works, right? What about the next one? What about 8 plus 17? 8 plus 17. Is that greater than 15? Well, 17's greater than 15, so that definitely works. I'm not even going to waste anybody's time. That definitely works. What about finally 15 plus 17? Is that greater than 8? Well, same reason there. It definitely is greater, so that one totally works. What about this guy? Can we make a triangle out of, if we have 3 pieces of metal or 3 pieces of wood or whatever, can I make a triangle with these 3 boards? Right? Can that happen? So is 6 plus 8 greater than 14? 6 plus 8 is 14. So no, you can't do it because 14 is not greater than 14. That is not going to work. This is not happy. So no, this one would be yes. This one would be no, because 6 plus 8 equals 14. Right? Easy peasy, lemon squeezy, and that's actually it. That's all there is to this lesson. We're not covering anything else. Well, we've got one more lesson in this unit. We're going to talk about hinge theorem and some other things like that. And then we'll be through with this unit. See you guys later. Hope you're having a fantastic day. Adios. Bye-bye. This year, when I'm recording it, happy Thanksgiving. All the things. See you later. Bye.